how do we push the efficiencies of PM systems? How do we reduce those disadvantages of PM systems, such as temperature effects as the magnet, such as how do we retain the magnets on the surface of the rotor? How do we reduce joule losses on the rotor? How do we make those as power dense and as efficient as possible? And then lastly, some considerations for your machine design are the material limitations and how we are innovating those materials. So we can use improved steel saturation characteristics to reduce core weight and volume. Many of you know that we can use high cobalt, non-grain oriented electrical steels to increase those saturation levels from, say, roughly 1.7 Tesla above 2 Tesla to 2.2-ish Tesla. So we can improve the flux density characteristics of the steel and make the system smaller overall. Another would be better PM materials to increase air gap flux density and avoid demagnetization. That can be with the really high-end samarium cobalt materials such as Ricoma 33E. That can be with some grain boundary dysprosium diffuse materials that we'll speak about. Next would be innovative winding configurations. Litz wire, formed, compressed wire. How can we get as much slot fill in between those teeth on my stator as possible to really keep our flux density as high as possible? We know there's a trade-off from hand winding to get a really high slot fill to machine winding to reduce the cost in your production applications. Next would be Halbach configurations. We will go through a Halbach configuration topology analysis showing some of the trade-offs on what route you go with your design. Laminating magnets, and lastly, carbon fiber sleeving. So all those things are limitations, but we have new innovations that can reduce the disadvantages and the limitations of your topology. So there are leaps in development of new materials and that's key in enabling high power density propulsion motors for a variety of industries from which I'm sure you are all from.